Hello again. In this section, we're going to start to build on some of the stuff that we looked at in the last section. Now, to start off with, I'm just going to put some reminders up the top. So, if we're working with carbons in this section, we know that it has 4 electrons on the outer shell, and we want to form 4 bonds. 4 covalent bonds with any carbon that we come across when we start making any of our chemicals. And if we are making any of our organic chemicals and there's a hydrogen in there, it has 1 electron on the outer shell, and we want to form only 1 bond. If any of our atoms at any time have a different number of bonds than the things that are up here, sort of on our cheat sheet or our cheat column, we've done something wrong. It's kind of like an illegal move in the grand scheme of things. So that's not something that we're looking at doing when we're making any of this stuff, and we'll sort of follow those rules as we go along. Now, first off, when we're looking at organic chemistry, there are many different kinds of organic chemicals. There's some very complicated ones, things like maybe proteins, especially those of us that are in bio would have been looking at proteins, maybe even seen some chemical structures of some proteins. They're pretty nasty chemicals and are very, very, very hard to name. We usually just sort of map them out and look at what they look like. There are other things that sort of go around in circles and all sorts of weird things. The main parts of the chemicals that we're looking at in this topic in the organic section, module 7, is straight chain organics. Pretty much every single chemical that you will come across forms a straight chain. The main structure of all of the stuff that we're looking at are carbon molecules that are strung up in some sort of chain. Maybe it looks like this. So this is a chain of 6 carbons. Now, you won't see a chemical like this. Reason being, we haven't followed our bonding rule. There are no carbons here that have followed the 4 bond rule, which means none of them are happy because none of them have a full outer shell. Now, to do that, the general rule is if there's an open spot when we're drawing up a molecule, fill it up with hydrogen. So here we've drawn up this chain, but it doesn't fulfill any of the rules that we've kind of already established when we've been looking at our covalent bonds and our Lewis dot structures and all of that sort of stuff. So generally speaking, we have to fill everything up with hydrogen until all of our carbons have 4 bonds around the outside. So this first one that I've done, 1, 2, 3, 4 bonds, it's happy. If we look at the second carbon though, there are already 2 bonds that it has, so it only needs to be filled up with 2 more hydrogens. Then we look at the next one, it has 2 bonds as well, so it only needs to be filled with 2 more hydrogens. Again, the next carbon has 2 bonds, it needs to be filled up with 2 hydrogens. Same for the next one. And then our bookend, our last carbon there, only has 1 bond so far. So like the other bookend on the other side, it will have 3 hydrogens to fill to make 4. And then we've already fulfilled the hydrogen rule. Every single hydrogen that's currently attached to this chain is only attached to 1 carbon. They all have 1 bond. So all the rules have been fulfilled. Now, when we start looking at straight chain organics, there are 3 sort of basic types of chemicals that I want to introduce first. And using these, we can sort of play around with some naming rules and whatever before I introduce all of the other functional groups that you've started to look at when you were making your table yesterday. So I'm going to start with these first, our alkanes, our alkenes, and our alkynes. Now, alkanes have only single bonds. Probably doesn't mean much at the moment. When I talk about alkenes and alkynes and I talk about double and triple bonds, it'll make sense in a minute. But the example that I've drawn up here is an alkane. Every single bond that you see here is just a single covalent bond doing its thing. So I'll link that up there as an example. An alkene, though, has a double bond. And this should be the functional group that you searched up or found when you were looking at your table again in the last activity. So that double bond will look something like this. It's a carbon, and then there are two covalent bonds happening at the one time and another carbon. If I did a Lewis dot structure, what that means is if I have a carbon on this side and a carbon on this side, that let me get my red pen. Each carbon is sharing two of its electrons and forming two covalent bonds. The other two electrons would be hanging out and maybe bonding to something else. So if I was to draw that in a chain, it might look something like this. I'm going to draw two carbons with a double bond. And then I'm going to draw a chain with an extra carbon. So 3 carbons in total. This carbon on the outside has 2 bonds already. So when we're using our filling with our hydrogen kind of deal that we were doing before, it only needs 2 extra hydrogens, 2 extra bonds. The carbon that's in the center has 3 bonds. So it only needs 1 extra hydrogen to make up its 4 bonds, and it's happy. And our last one here has 1 bond already to one of the carbons. So we're going to fill it up with 3 hydrogens to finish it off. And again, fulfill our 4 bond rule. Alkynes are our next one, alkynes. And they have a triple bond. I'm hoping by this stage you can kind of hypothesize or appreciate that. That probably means, again, there's going to be 2 carbons and there's going to be 3 bonds in between the carbons. If I was doing a Lewis dot structure, that would mean that the carbon on the left is offering up 3 electrons, and the carbon on the right is also offering up 3 electrons, and they form 3 covalent bonds. This carbon over here has 1 electron left, and this carbon here has 1 electron left as well, and they can be used for other bonding too. If I was to draw up an example of that, again, I'm going to draw up a chain of 3 carbons. The 2 carbons on the left are going to form a triple bond, and this one's going to form a single bond. Now, after that, we have to fill the rest of the carbon up with hydrogen to make sure that we follow our 4 bond rule that we sort of came up with before. This first carbon has 3 bonds already. It only needs an extra one to make a 4th, so it's only going to be having 1 hydrogen attached to it. The carbon in the center has 1, 2, 3, 4 bonds around it, so it's fine. It doesn't actually need to have any other hydrogen attached to it. If it did, it would be upset. There'd be too many electrons. So that means that there's only 1 more carbon to look at, and that's one on the very right. Now it's only got 1 bond. So again, we fill it up with 3 hydrogens to total up to 4. Now, after this, I'm going to start talking about how we can name some of these organic chemicals. And we're going to be focusing on things like chain length. So chain length, how long the carbon chain is a factor in naming. The other thing as well is the kind of functional groups that exist. So is it an alkane, an alkene, or an alkyne? Catch you in the next one.